Hello everyone. Welcome you all to Sri Jaindra Rank Zone classes. I'm your mentor and your friend for the subject chemistry, and I will be taking organic chemistry. My dear students, as you know that we have started hydrocarbons in the previous terms, we completed the physical properties, we completed the uses. Today I'm going to start with the uses of benzene and some miscellaneous topics, which includes some specific polycyclic compounds and most importantly, the allotrope of carbon, the third allotrope of carbon, that is Buckminster fullerenes. So starting with uses of benzene, benzene is used as a solvent. Benzene is used as a solvent. Okay, in the laboratory and the industry. In the laboratory and in the industries. Okay, benzene is a very good solvent. As you know, the condition of like dissolves like. The carbon-based compounds are non-polar, and if they are non-polar, they will be only soluble in non-polar solvent like benzene. It may be used in dry cleaning of clothes, so it is used in dry cleaning of clothes. Cleaning of clothes. Okay. Third point. It is used as a fuel in combination with petrol or alcohol. It is used as a fuel in combination with petrol or alcohol. Okay. Fourth point. Benzene is used or it is treated as a starting material. It owns as a starting material for the manufacturing of numerous organic compounds. Numerous organic compounds on which various chemical industries are based. Various chemical on which various chemical industries are based for the production of chemicals, dyes, plastics, okay, explosives, etc. There are some products of commercially importance. It also used for manufacturing commercialized products. like nitrobenzene, 1,3,5 trinitrobenzene, Gavaxine, also known as lindane, which is the fertilizer, phenol, adipic acid, and so on. So, these are some common commercial and laboratory uses of benzene. Okay, it's a very important organic compound which is used to make, okay, different other compounds. Now, in the starting of this aromatic hydrocarbons, I introduced aromaticity. I discussed about that how aromatic, anti-aromatic, and non-aromatic compounds are separated and what are the different characteristics. Okay. Now, there are many compounds having multiple, cyclic rings known as polycyclic compounds, as we have discussed. Okay. So, as far as JE is concerned, there are some common questions which come. Okay, like applications of Huckel rule in explaining the structures, the stability of different structures. Like furan, I'm just giving you example. Okay, if you want to make a picture of cyclic delocalization, okay, you can see, because Huckel's rule is basically based on the linear combination of atomic orbitals. Okay, so if I'll make the diagram, okay, 1, 2, 3, 4, 5. Two p electrons. This is sp2 hybridized. Okay, this is sp2 hybridized orbital, and you can see the cyclic delocalization of these electrons in these pure p orbitals. So in this way, you can see that how these orbitals are actually coming up with this cyclic delocalization. Okay, so then actual structure comes to be this. Okay, wait a minute. I'll I'll make the complete diagram because by mistake I have made six atoms, six carbon atoms. Okay. These are two p electrons, pure p orbital electrons. This is sp2 hybridized. Here you can see the cyclic delocalization. This. Okay. Yeah. This native structure comes furan, which is an aromatic compound. Here you can see the cyclic delocalization of 6 pi electrons. Okay, 2 here, 2, 3, 4, 4 plus 2, 6. Okay. In the same way, if you read the structure of pyrrole, this is pyrrole. It's also delocalization, cyclic delocalization of 6 pi electrons. Okay. The final structure came to be like this. It is also aromatic. In the same category, pyridine also comes. Okay, which is also an aromatic hydrocarbon, aromatic compound. As it's a heterocyclic ring. So these were the applications of Huckel's rule in explaining the stability of all these compounds. Okay. There are some questions which come that Huckel's rule also explain the stability of different cations like cyclohepta triennyl cation C7H7 plus Okay. Cyclopentadienyl cation. Okay. So the bases remain same. You have to just practice. I'm just giving you an example that these examples majorly come. Okay. That okay, these compounds are explained. Cyclopropenyl cation, C3H3 plus. Okay. Anions also same as above. In cycloheptatrienol anion, cyclopentadienyl anion, cyclopropyl anion. Okay. So these are the applications of Huckel's rule in explaining all these compounds, the stability of all these compounds. Okay. Now coming to that, we have to discuss the last category, that polycyclic compounds. I have already given you a glimpse that what are the different polycyclic compounds. There are certain aromatic organometallic compounds. I'm giving you an example like ferrocene. Okay. Fe2 plus. This is ferrocene. Along with it, tropylium chromium tricarbonyl. Just remember the name. Okay. There are many more. I'm giving you two examples. You just remember the name. Okay. Now talking about lastly about fullerenes. Fullerenes, as you know, they are polycyclic aromatic compounds. C60 molecule, C60, C70. Okay, which is known as what? Buckminster fullerenes. Okay, which is given the name in the honor of American architect Buckminster Fuller. Okay, who designed geodesic domes. Buckminster Fuller, architect, who designed geodesic domes. They are also known as buckyballs. Okay, it was first isolated by Harold W. Croteau of United Kingdom and Richard E. Smellie and Robert F. Krull of USA. Richard and Robert of USA. Okay, and they have been given Nobel Prize in the year 1996. Okay. Now, the method consists of basically they are prepared by vaporization of graphite by passing an electric arc through graphite rods. Through graphite electrodes. Okay. C60 fullerene, it consists of 32 interlocking rings out of which 20 are 6-membered, hexagonal rings and 12 are 5-membered. All the 60 carbon atoms are found to be in equivalent and all are sp2 hybridized. All are sp2. Six-membered rings are fused to six and 5-membered rings both, but 5-membered ring only fused to 6-membered ring. Okay. So this is about the Buckminster fullerene. Okay. Although C60 is less aromatic than benzene due to strain, okay, introduced by the curvature of the rings, it reacts with osmium tetraoxide okay, which are shared by two 6-membered rings. It can also be doped by inserting potassium or cesium into its cavity. Potassium or cesium into its cavity. Okay, my friends, that will be all for Buckminster fullerene and the benzene. Till then, bye bye. Take care. Stay safe. Stay healthy.